Are there any leftovers from 10.1 and 10.2 that we need to still go over? Any that gave you problems? We had all those fractional ones that were in 10.1b that you had to complete squares on. Were those okay? And going through and making sure that you get half of it. So if you take half, remember it's always going to be over 2, whatever that number is. So if you had something with a 5 in the middle, you're going to have a 2 underneath it. When you square it, you're going to put it on both sides. So be careful with that. 10.2 was where we had to use the quadratic formula, and we're going to use that again today. So what is the quadratic formula? Anybody tell me what it is? You've practiced it enough. What should it be? Negative b, plus or minus of b squared, all over 2a. Yes, perfect. We're going to use that a lot today because we're going to have story problems that are going to get us into using and figuring out quadratics. It's a little easier to use this than to go back and complete squares. I wouldn't want to do that with some of these today because the numbers are kind of big. Also, it's a little easier than trying to factor stuff because you got something to just hop back into and come up with what your solution happens to be. So we're going to use this thing today. It's going to be part of our problem solving when we get around to doing those. So be careful with that. This discriminant under here told us a lot in 10.2. It told us whether we had 2 solutions. So that's if what happens inside of here to have 2 solutions, 2 real solutions. What would come out of this? We had 2 real solutions under there. So what we'd end up with is that there'd be a positive number under here. So it might be 12, it might be 15, it might be 1, it might be 3, who knows? But something positive coming out of there. If we had 1 real solution, this whole thing turned into 0, yeah. And because it turned into 0, we ended up not having anything, of course, in there. And there wasn't a number here, which made this only be 1 answer, because all I was left with was a negative b over 2a. And then the last one is if it came out negative. We know we can't take square roots of negatives, but at the end of chapter 9, we found we could pull an I out and make them imaginary or make them non-real. And so you'd end up with 2 non-real solutions. So this little piece tells me a whole lot about what my problem's going to do. So we need to be aware of that. So today, we're going to end up having probably 2 real solutions in most cases coming out of here. And so we're not going to have to worry about that other piece. So let's move on to those. I handed out to you the listing of the story problems that we're going to go through today. And so you have that as a sheet. And it's there for you to use, of course. You don't have to write like crazy and try to write in what that story problem happened to be. So it's applications in 10.3. And again, the applications are, of course, our story problems. And we've dealt with some of these before in other places, but we haven't really used quadratics to solve them. So first off, again, solving applied problems. So we're going to have those pieces in there. And then the strategies, understand the problem. That's always the best plan here. And then we're going to read the problem carefully, and it helps to restate the problem in your own words sometimes. So we're going to look at that part. We're going to come up with a plan. And remember, all of these story problems have to come into it, end up being a quadratic equation. So if you're solving them and you do not have any x squared in your problem, you did something wrong. So we need to have those. So devise a plan, and then sometimes that means assigning a variable to an unknown quantity and label this variable so you know exactly what it represents. So we're going to maybe not use quite as many x's, or we might still end up using x's to represent some of these as we go through those. And then the next phase is we need to maybe draw a diagram and set up a chart whenever possible. Write out the equation, and then finally carry out the plan. Now, some answers are going to come out to be negatives, and if we're looking at a distance, we can't use those. So we're going to kick some answers out when we do these, and then we're going to solve it and come up with what it would be, and then finally look back over the results to see if what our solution happened to be ends up being the correct answer or not. Does it make sense? Like I would not use negative $32 because I can't have somebody pay for someone in situations that we have in these. So the negative 32 would be kicked out as an answer. So that ends up being our process with these. So we've got the Pythagorean Theorem is one of the processes that we use because we get squares out of all of this. So the Pythagorean Theorem is basically stating a leg squared or b squared plus a squared is going to equal my hypotenuse squared. And so if we know our sides of our triangle, we can end up finding the hypotenuse. Or if we know the hypotenuse and we need to know some pieces of information about those legs, we can end up finding out what those legs happen to be, or sides of a rectangle is how we're going to use it in here. So that's the Pythagorean Theorem. And so that ends up being a piece that we need to use. Now these are examples that are in here. There's 3 of them, and then we will go to your sheet. There's a few that we need to take a look at that were in the PowerPoint stuff so that we can go through those and see what happens to them. It says the length of a rectangular field is 6 meters longer than its width. So the length and the width of this playing field is what we happen to have. From one corner of the field to the opposite corner is 30 meters. So if you cut right straight across it, you end up with 30 meters. So what we have in this situation is the Pythagorean Theorem, because that corner that's here is forming a right triangle, and so therefore we know that we're getting a right angle in here, which means we can use the Pythagorean Theorem to solve it. Notice my length is w plus 6, and my width is just plain straight width, because it states up here that the length of the rectangle is 6 meters longer than the width. So the width is w, this length is w plus 6. So now the next piece we need to do, and I don't know if I can leave everything up there, which I probably can't, is to go through and solve this thing. So what happens when I solve it? So the Pythagorean Theorem says a squared plus b squared equals c squared. And if I know a is my length, so w plus 6 squared, b is my width, w squared, and c happens to be 30 squared. And so that's my equation that I gather out of this. We good so far in figuring out what pieces we happen to have? So they had drawn the picture for us, but we'll have some in our story problems that we'll have to draw ourselves so that we can end up figuring out what we get for those, for our answers with the Pythagorean Theorem. So now let's solve it. Let's see what we can do with this. So if I solve it, I need to get this whole thing equal to 0, because if I get it set equal to 0, then I can plug it in that quadratic formula and figure out what my answer will be. So what is w plus 6 squared? Well, w plus 6 times w plus 6, or I FOIL it, I get w squared. 6w and another 6w is plus 12w. And 6 squared finally at the end is 36. Plus a w squared. But what's 30 squared? So we need to have our calculator for that one. So let's square the 30. And we end up with 900. So far, so good. Combine some like stuff. W squared and w squared is 2w squared plus 12w plus 36 equals 900. Subtract 900, and that leaves me with 2w plus 12w minus 864. And that is all going to end up equaling 0. So once I get it to that format, then what can I do to it? Well, quadratic equation or quadratic formula we can end up using. So a is 2, b is 12, and c is a negative 864. So your numbers are going to get pretty large with some of these story problems. So if I plug them in, I have a negative 12 plus or minus the square root of 12 squared minus 4 times 2 times a negative 864 all over 2 times 2. And then I can finish it out from there and come up with what my solution is. That pen's writing kind of nasty, so we'll switch to a black one. Maybe that'll make a difference. So if I grab my calculator and work this piece underneath, or the discriminant out, I'm going to have 12 squared minus 4 times 2 times a negative 864. And underneath my radical, I get that answer. And so now I want to take the square root of it. So if you're on your calculator and you got to take the square root, what you can do is go second square root. And if you want to put this number underneath that radical, down here above your negative sign, there is, it says answer. If I go second answer, it will put that answer in there. And if I hit enter, I will end up with 84. So negative 12 plus or minus, 84, all over 4. So that's what it will equal. So then go through and do my math. A negative 24 plus 84. It's going to give me 72. 72 divided by 4 will give me 18. The negative route, negative 12 and a negative 84, will I use that? What do you guys think? Negative 12 minus 84 is going to give me negative 96. Divide by 4 will end up giving me a negative 24, but I can't use that answer because it's negative. And my distance, if I go back to my drawing, I can't have a negative distance in here. So in my drawing, what's my sides? So W equals 18. So this side is 18. This side is 18 plus 6, or 24. And it says, what are the dimensions of the field? So it's 18 meters by 24 meters. Okay. So we just used Pythagorean Theorem and also our quadratic to take that and solve it. So questions with this one? Or are we so far so good with that one? Hopefully we're okay with it. So again, it's solving it, plugging it in, and coming up with what its conclusion happens to be. These, example 2, are the projectiles, and they give you a formula with these. The formula is this, and that will always be provided, regardless of whether it's on your Hawk stuff or in a test, you'll have that formula. It says a bullet is fired straight up from the ground level with a muzzle velocity of 220 feet per second. So every time something goes up, each second it's going to go 320 feet up in the air. Now the reason we use this, the quadratic, is because if you remember way back, we were at the beginning of chapter 10, we're talking about the parabola and where it crosses. So in this case, you're shooting from the ground. The bullet's going to go up, but what happens to bullets? They'll go up a certain distance, and then they come right straight back down again. Okay? So they're going to come back down, and they're going to end up eventually hitting the ground. So if you fire a gun up in the air, it's going to come down at some point. So there have been people who have been killed by bullets at New Year's Eve. New Year's Eve, there's a lot of people who will go out and shoot their guns off at night at midnight. And the person who's killed's not even near where the person shoots the gun off, but as that bullet comes down, it has hit people. They may have been a distance away. So you end up having accidents that can happen because once it goes up, it does come back down. And it comes down in a different spot, in a different location than where you're at. So what do we have in this situation? Well, we have when a bullet hits the ground. So we want to know when it's going to hit the ground. So what we are looking for is what this answer is going to be. So what would that end up being? So now I got to plug in my pieces. So it says when the bullet will be 1,200 feet above the ground. So we want to know when that's going to happen. And we want to know what's going to happen with this for a solution. So VO, or V subscript O, is 320 feet per second, because that's how high it's going up each second. HO is how far off the ground are you shooting it. So this person happens to be laying right on the ground. They're shooting it at 0, so that's right here. And so they're shooting it, and it's coming up, and it's landing somewhere over here. So we need to find out where that point is that it lands at. So we're going to take that equation. Let me get it over here. H equals a negative 16 t squared minus VOT plus HO. And we're going to take that equation and plug our numbers in. So I'm going to have H is equal to a negative 16 t squared. Where the VO is at, I'm going to put the 320. And where H is at, that is the height that the bullet is off the ground. So that's where the 0 is going to go in at. And so now I have a quadratic equation, and I can use my quadratic formula to solve that. So A is a negative 16. B is a negative 320. And C is 0. So plug all my pieces in. So I'm going to have a positive 320, because it was negative originally, times a negative 320 squared minus 4 times a negative 16 times 0 all over 2 times a negative 16. And in this case, it's going to equal H. So what happens to that? So if I go through and finish it, I get plus 320. Under here, the only thing left is the square root of negative 320 squared. So 320 squared. Do I really need to do that? I'm going to go back and take the square root of it. So because if I square it, it's going to come out positive. If I take the square root of it, it's going to come out to be that. I guess I better put it under there. And it's going to come out as 320 over a negative 32. So I have two routes in this case. The first route is 320 plus 320 divided by 32. So 460, or 640, I should say, divided by 32 is going to equal 20. So what I have found is that in 20 seconds, that bullet will be back to the ground. So it's going to go up, go back down, and in 20 seconds, it's going to end up crossing at the ground level for that one. So everybody okay with that? Plugging in our numbers, making sure we get them in the right locations, and coming up with what those happen to be. And so that ends up being the piece that goes into that. So are we done? Well, we want to know, we're not done because it says when will the bullet be at 1,200 feet above the ground. So that's going to change things a little bit because we want to know where is 1,200 at. So how high up here is it going to be at that point, and how many seconds would it have been up at that point? So what is this? This is the H that goes in place here. And so we need to plug that H in here and end up solving it to see what we can come up with for that one. So if we do that, and I probably won't end up finishing this one because I think maybe you got the idea of what we're doing with this. So negative 16t squared minus 320t. And from there, I can end up finding out what my t happens to be. Move this back over. And I can have solve that by putting it in my quadratic equation, and I would end up coming up with what t would happen to be at that situation. Okay, so does that make sense? What do you guys think? Yes? No? Okay. Plugging it in and making sure that you get your points in there and get your stuff to come out with that one. So again, it's watching and making sure that you get that. Grab this on the way back. With those. Okay, but again, you'd end up going through, getting your quadratic in there and coming up with what your solution would happen to be. This next one, they have a tendency to put a few of these into your homework questions, so we do need to, of course, take a look at it and figure out what we got to do with it. Again, they change these with what you have going on with your problems, so we'll take a peek at what happens with a bowling club. So they're going to go on a trip. So the members of the bowling club were going to rent a bus to drive them to a tournament at a total cost of $2,420, which was to be divided equally among the members. So if I knew how many members I had, I would just simply take that, divide it by the numbers of the members. At the last minute, 2 of the members decide to drive their own cars. The cost to the remaining members increases $11 each. How many members rode the bus? And it's kind of like, oh, why don't they just tell us how many were on that bus and be done with it, huh? But then we wouldn't get a quadratic, right? So they kind of have to leave you with a mystery in there. So if all members went, we would take the 2,420 and divide it by the X members. Be good there. So that's just kind of a straight basic math type of situation. Divide it by the number of members, come up with what the cost would be. But doggone it, 2 members decide they're not going. They're going to do their own thing. So what happens is the 2,420 gets now divided by X minus 2 because 2 people are no longer going. And what did this do? It increases everybody's cost by $11. Okay? So when you do these, we want to know how many members rode the bus. So when you do this, what took place? Well, this increased. So when you set this up, it's going to be 2,420 over X minus 2 minus what the original members would have been paying to end up equaling that $11 that everybody now is going to have to pay, because it's the difference between these two and what's taking place. Follow, hopefully, of where we got that at? So we're pulling this stuff out of here and we're coming up with what these conclusions happens to be. This is going to be what we need to solve. So let's stick that on this blank sheet of paper in here so that we can end up solving it. So 2,420 over X minus 2 minus 2,420 over X is going to equal 11. So like I said before, our numbers tend to get pretty good size when we work with these. And so again, pretty big numbers in there. So we've did these, but when we did them in the past, we never ended up with quadratics. We always ended up with something that ended up solving. So because I have denominators in here, I'm back to chapter 7. Chapter 7 is where we had all those radical or rational equations. So to solve it, I need to clear out my denominators. And that means I need a common denominator of X minus 2, another X because that's the other denominator, and then what happens? So now I gotta cancel stuff out. So X minus 2 is used, so I need to multiply 2,420 by X. Then the minus 2,420, the X's cancel, and I multiply it by X minus 2. And finally, 11 gets multiplied by the whole thing. So it gets multiplied by everything that's in there. So I have 2,420x minus 2,420x 2 times that is going to be a plus 2,420 times 2 is going to be 4,840. X times, or 11 times this whole piece is 11x minus 22 times x. So x times 11x is 11x squared. X times 22 is minus 22x. And so then I can end up getting it all on one side. These two cancel out. So I minus 4,840 from both sides. And I'm left with 0 is equal to 11x squared minus 22x minus 4,840. So far, so good. Basically cleaning out denominators and getting rid of them. So I could look at that and say, can I factor it? Oh, I don't know whether I could or not. So let's just use our quadratic. A equals 11, B equals a negative 22, C equals a negative 4,840. And just plug them all in. So a negative B, so I'm going to have a positive 22. Under here, I'm going to square B minus 4 times A times C all over 2 times A. And then what comes out of there? So now I got to do that discriminant underneath. So 22 squared. I don't really need the negative because I know it's going to come out positive. 22 squared minus 4 times 11 times a negative 4,840 equals that. And that's a great big number. And if I take the square root of it, second square root, second my negative sign to put my problem in there, hit enter, and I get 462. So I have 22 plus or minus 462 all over 22. And so now I can work it out. The negative route I don't need because I don't have negative members. So 22 plus 462 equals, divided by 22. And I find out that I had 22 members. So 22 members went on the trip, or how many members rode the bus? So if there's 22 members altogether, how many rode the bus? Because that's my answer. So how many rode the bus? If I've got 22 to start with, I know that 20 rode the bus. Because 2 decided to drive themselves. Okay? So that becomes my answer. Questions with this stuff? Are we so far so good? Okay. The next ones are all of the ones I handed out to you. Let's see, I gotta take one back here. Brendan, here's the stories that are going up. So we'll set some of these up, but maybe not necessarily put them through and go do the quadratic with them. I think it's the setting up that's probably the tougher of the two. And so let's see what we can do with these. This first one is like the others that we did. We did one just like that with the rectangle in there. So I don't know. Again, you would draw out your rectangle because it says the width of the rectangle is 7 yards less than the length. So length minus 7 and length. If the diagonal measures 13 yards, what are the dimensions of the rectangle? So it's a Pythagorean Theorem one. And so you would square your length plus your width squared is equal to the hypotenuse squared. Think we're good with that one? What do you guys think? Do we need to finish it? Or can you guys finish it? Not hearing anything out there. Can you finish it or not finish it? Well, I guess we'll go through it. Length squared is L squared. L minus 7, I need to square it. So to square it, L times L is L squared. 7, negative 7 and another negative 7 is a negative 14L. 13, and then negative 7 times a negative 7 is a plus 49. And 13 squared is 169. Get everything put together. So 2L squared minus 14L. Move my 169 over, and that's going to end up leaving me with 120 equals 0. So then from there, we can put it into the quadratic formula and end up solving it, or divide everything by 2, because what you might find is that you can just factor this one. So if I divide everybody by 2, I get L squared minus 7L. 2 goes into there, 60 equals 0. So this one actually factors. 60 is 5 and 12. And so 5 from 12, so I got a negative 12 and a plus 5. And so L minus 12 equals 0, so L could equal 12. Minus 5, or L could equal a negative 5, but I can't use that one. So my length is 12. My width is 12 minus 7, or my width happens to be 5. And so that is my solution to this one. So sometimes they do factor, but if you can't factor them, just hop in and do the quadratic. It works probably just as fast as factoring when you work through those. And then the bottom one, it says a bullet is fired straight up from 6 feet above the ground. Now this one's changed because instead of H subscript 0 being 0 like our last one, it's going to be 6. And the muzzle velocity is 340 per second, so that's the VO. When will the bullet hit the ground? So I have H is equal to negative 16t squared minus 340t plus 6. So the only thing that changed between this one and the other one we did is that our height changed. So now it's just put it into your quadratic formula and go from there. Do we need to do that part? Put it in a quadratic? Okay, yeah, we can do it, sure. So A is a negative 16, B is a negative 340, and C is a positive 6. So I'm going to have a positive 340 plus or minus the square root of a negative 340 squared minus 4 times a negative 16 times 6, all over 2 times a negative 16. Okay, so what does it work out to be? So if we plug it in here, we need to figure out what that discriminant happens to be underneath. So 340 squared minus 4 times a negative 16 times 6 equals that answer, but I know I got to take the square root of it. So second square root, second, and my negative will put that answer under there that I had. I don't have to type it back in. Hit enter, and I get that for my answer, 340.564. So plus 340 plus or minus 340, and we're going to round it off to the nearest tenth, so it's going to be 340.6 all over a negative 32. So now if I finish it and I go my positive route, so this plus 340 equals that, but when I divide it by a negative 32, it becomes my wrong answer. okay? So it's not going to be the correct answer that I need because it's negative. So I can't have a negative value with this because I can't have a negative time. So then if I go the other route and I take 340 minus 340.6, I get a decimal, divide that by a negative 32. So what happens with this firing of this gun is it doesn't stay very long up in the air at all, and I get 0.01875. So it's not very long that it's shot up and it comes right straight back down again. And so that becomes where it's crossing at for my seconds. So that's when it's going to hit the ground. So not very long, okay? So they're not shooting it very high up in the air. So this one's kind of a strange one because it comes out with a decimal representation to it. So just be aware that it can come out to be kind of small when you work those out. So be aware of that part. Okay, let's keep going then. Let's see what the next one happens to be. Next one's the ski club with a charter bus. And that's like the other one we did. And again, they like to put a few of these into your problems to work with. So let's see if we can set it up. So it's like that last one. So a ski club is planning a charter bus to a ski resort. The cost is $900, and each member will share the cost equally. At the last minute, 15 more members decide to go on the trip. The cost to each of the members will be $10 less. How many members are going on the to the ski resort now? So what do I have? Well, originally, 900 divided by the number of members. So that's pretty straightforward. Yep, that's what they're going to pay. But then 15 other members join, so that 900 gets divided by a different base. And that's going to save them $10. So if I put this together, this is what needs to go first this time. So 900 over x plus 15 minus 900 over x is going to equal the difference of $10. So we get a difference of 10. I know it makes you think that 10 needs to be negative, but because you're reducing it by what they would have paid, you're coming up with that $10 in there. So then, same as we did before, multiply it by its common denominator. And so x plus 15 cancels, so I have 900x. This one, the x cancels, so I have minus 900 times x plus 15. And finally, the 10 is going to get multiplied by the x and the x plus 15. And then you multiply and distribute and get everything to work out from there. 900 times x is a minus 900x. 900 times 15 is a negative, oh, let's get my calculator over here. I'll have, if I didn't have other answers in there. Will equal 1,300 or 13,500. 10x times x plus 15 gives me 10x squared plus 150x. These 900s cancel. Move that guy back over. 0 is equal to 10x squared plus 150x, or plus 13,500. And then you'd plug it in your quadratic. Do we need to do the quadratic piece? What do you guys think? Or can you do it from there? Can do it from there? Think so? Okay. So you just plug those in. Again, your numbers are going to get huge. So just remember that you've got to come up with those and go from there. The answers that end up coming out of this is going to be your numbers that you're going to come up with is x going to equal 30 when you are all done with those. And so remember that that's what's going to happen with that part. So then, next one, the Franklins have a rectangular swimming pool that is 8 feet longer than it is wide. So here's our rectangular swimming pool. And it is, the pool is 8 feet longer than it is wide. So W plus 8 and W on the side. Then it says the pool is completely surrounded by a concrete deck. Oh, concrete deck goes around there. And that deck is 7 feet wide. The total area, this one's a little different because it's not the Pythagorean theorem. The total area of the pool and the deck is 1,678 square feet. Find the dimensions of the pool. So what does this 7 do? Well, that 7 adds 7 feet in both of these directions, or actually 14 feet to what you have. So our width down here is W plus 14, and our length is W plus 8 plus 14. So you've got those additional pieces in there because it's the whole area. So 8 plus 14 is 22. So I have W plus 22 squared, or not squared, times W plus 14 is going to equal 1678. So some of these are a little tricky when you get into putting your pieces together. So you want to make sure that you get your sections together in there. So then what comes out of this piece? So I've multiplied this out. W times W is W squared. 14W and a 22W is a plus 36W. And last, 22 times 14 is 308. Move the 1678 over. And I find that I have W squared plus 36W minus 1370. And then I can put that into my quadratic formula. Yes or no? What do you guys think? Mm-hmm.
Under the square root, it's negative.
Oh, it is? Oh, okay. All right. Well, then I maybe what I did, let me see here. Maybe what the issue is, because it shouldn't become out negative, is I think I have these two backwards. Those two got to switch. So let's switch those two around. And so we're going to have 900 over x minus 900 over x plus 15 is equal to 10. If I do that, I think I'm probably on the right track. I think I got them backwards, because you got to go from the original minus this is going to end up giving you your 10 difference between the two. So let's try that one and see what happens. So let me get a sheet of paper in here and we'll rework that. Thank you for checking that. I guess we needed to go through and do that quadratic, because then I would have found that. So again, we're going to multiply this 900 over x minus 900 over x plus 15 equals 10. We're going to multiply everything by x and x plus 15. And so that cancels, so I get 900 times x plus 15 minus 900 times x is equal to 10 times this. Let's see what happens now. So I get 900x. 900 times 15 is 915. No. 900 times 15 equals 1350 minus 900x equals 10x plus 10x times x plus 15, or 10x squared minus 150, or plus 150. So then, if I put these 900x's together, they cancel. So I have 13,500 is equal to 10x squared or plus 150. X, when I move it over, that was what the problem was. So now I'm going to have 0 is equal to 10x squared plus 150x minus 13,500. Now it'll work. Okay, I had them backwards in there. Thanks for catching that and getting them in the right spots for that one. So now if we finish it, let's go. A is 10, B is 150, and C is a negative 1,000 or 13,500. So I have a negative 150 plus or minus the square root of 150 squared minus 4 times 10 times a negative 13,500 over 2 times 10. 150 squared minus 4 times 10 times a negative 13,500. And I get this great big number, 562,500, square root of it. And I get 750. Now we're better, over 20. So then if I finish it, 150, negative 150, plus 750, equals 600, divide that by 20, and I find I get 30. There. Now we're in the right track. But if you go the negative route, it's not going to help us, so we can't go negative. So there were 30 members that originally signed on to go with the bus. Okay, we got that one figured out now? Okay. Sorry about that, and getting that piece in there. I'll stick it right in there so it's in the notes. And I'll cross off the other one. There. Okay. Now, we good here on this one, you think? With our rectangular swimming pool? Hopefully. Next one. The next one is find the negative real number. Negative. So I know my answer has to be negative when I get done with this one. That the square of the sum of the number and 20 is equal to 25. If there are two correct answers, either answer will be entered or can be entered. So what do I have? Well, if I read this, it says that the square of the sum of the number and 20. What does that mean? The sum of the square, or the square of the sum of the number and 20. So that means I need to take my number, add 20 to it, square it, and that's going to equal 25. So what does that look like? We just had a whole bunch of those in the last few sections. What did we do to those when they look like that? Got a square on one side and another number on the other side, and we worked with those when we completed the square. Take the square root of both sides. Perfect. And so when I take the square root of this side, I end up with x plus 20. So square root of 25 is going to be a plus or minus 5. Remember, you've got two routes to go with these. Don't ever just put 5. So x is going to be, and minus 20 from each side, is a negative 20 plus or minus 5. So my answer is a negative 20 plus 5, or a negative 15, or it's a negative 20 minus 5, or x is a negative 25. Both answers will make that thing work. So if I put it back in, a negative 15 plus 20 is 5. 5 squared is 25. A negative 25 plus 20 is a negative 5. And a negative 5 squared is also 25. So I know I did my math correctly with that one. So that one's kind of a nice one that they threw in there to help you out and give you something that's a little simpler to work with. Next one. Two companies working together can clear a parcel of land in 8 hours. Working alone, it takes company A 4 hours longer to clear the land than company B. So what do we know? Well, it takes company B X hours. It takes company A X plus 4 hours, because it's 4 hours longer. How long would it take company B to clear the parcel of land alone? Round your answers to the nearest tenth. So he wants to be getting some decimals in here. So to set this one up, this goes way back to, I can't remember which chapter it was, but we had work problems somewhere along the line. And so I have to set these up as 1 over x plus 4, because I need to get them based on an hour. I guess it was chapter 7 was where we had those. Plus company B, this is A, this is B, and they can do it together in 8 hours. So I'm going to end up with 1/8. So if I get that so that I have my fractional pieces in there, then what happens is I got to clear them out. And when I clear them out, I need to multiply sides by x plus 4, x, and 8. And so x plus 4 cancels, so I have x times 8 times 1. Second one, the x canceled, so it's going to get multiplied by x plus 4 and 8. And finally, the 8 piece is 1 times x plus 4 times x. That's where the quadratic will come in, because you get an extra x at the end. So I get 8x. 8 times x is 8x. 8 times 4 is 32. And the end, x times x is x squared, and x times 4 is plus 4x. And put my stuff together. Move my 16x over, move the 32 over. And I find I have x squared minus 12x minus 32. And I think this one factors, yes, no, yes, I don't think it does. Negative 32, it doesn't factor. So I need to use my quadratic. A is 1, B is negative 12. What was that? Does it factor? Nope, you gotta watch. The last answer, last piece is a negative 32. It's got to both have to be, one has to be negative, one has to be positive. Okay? To get a negative 32 at the end. Yeah, I looked at that too and I thought, oh yeah, it would be those, but it's not because it's got to be a negative 32. Okay, so plug them in. We get 12 because 12 was negative, so it's going to be positive. The square root of a negative 12 squared minus 4 times 1 times negative 32 all over 2 times 1. And 12 plus or minus, and so we're going to finish that middle piece out. It's going to be a decimal because I've kind of hinted up there it will be. So 12 squared is 144 minus 4 times a negative 32. The 1 doesn't really make a difference. Gives me 272. So second square root, second answer, put it under, take the square root, and I get 16.5 all over 2. So 12 plus 16.5. Divide that by 2. I get x could be 14.2, or if I take it and minus it, I can't have negative time, so I can't use that part. So my answer is going to come out to be 14.2 hours, would be how long it would take. What are you thinking on these? Think they're going okay or not? Kind of? Okay. And again, I mean, I've got lots of examples in here, so I don't know. Oops. Nope, final answer was 14.2. Got it? Once I did my quadratic with it and figured that piece out. Okay. The hypotenuse, I think we're good there. Are we good there? What do you think? Can you guys set that one up? Okay. Now, again, be careful. It's got the right triangle is twice the length of one of the legs. So the hypotenuse of the right triangle is twice. So we'll just draw the triangle out and maybe set it up here so that we know that. So the hypotenuse of the right triangle is twice the length of one of the legs. So 2 times x, and we're going to make one leg x. The length of the other leg is the square root of 27. Find the length of the leg and the hypotenuse. So within this one, again, you're going to take the square root of 27 and square it, plus x squared is equal to 2x squared. Okay? So when you take the square root of the square root of 27, what do I get? Again, chapter 9 coming in there. I get 27 plus x squared is equal to 4x squared. Okay. Get everybody on one side. So I'm going to minus 27 and minus an x squared. So I find 0 is equal to 3x squared minus 27. If I divide by 3, I find 0 is equal to x squared minus 9. Perfect squares. So I find x minus 3 and x plus 3 is what that would equal. So x could equal a negative 3 or x could equal 3. Can't use the negative. So find the length of the leg is 3, hypotenuse is 6. So I guess we finished that one and worked it out. Another rock climbing one. The cost increases, that's the plus. So we're going to do that one in order, and I'm not going to do that one because we did a couple of those already with that one. And then there's another hypotenuse one, so that's another example of that same thing. And if you want later on, look at these notes because I'll work them out, so you'll have them in there. And then the speed one, I guess we better look at that one. It says plane travels at a speed of 165 miles per hour in still air. And flying with the tailwind, so the wind is going to push it. The plane is clocked over a distance of 725 miles. Flying against the headwind, it takes 2 hours more to complete the return trip. What is the wind velocity? So if we chart this, like we did with these before, we have distance equals rate times time. And so we have with wind, against wind. And so what do we know about its rate of speed? It's 165 plus x, or 165 minus x. We know that it takes 2 hours more to do the other, so we got to get fractional values in here. So time is going to be the 725 was my distance, divided by 165 plus x, and 725 over 165 minus x, and it's 2 hours more, so it's going to be the speed of the wind minus the original distance to equal 2 hours. So it's kind of like those ones that have the trips involved. So it's kind of like a trip problem. I can't remember if this one does show up in your homework part. It may not. But we can solve it from there, do you think? And again, I'll finish these. I just didn't want to eat up all of our time of going through them to finish them up. But it's the difference between these two because it's 2 hours. This one takes 2 hours more than this one. So if I take this one minus that one, I will get my 2 hours that's in there. And then let's see, what's the next ones in here? Now again, I will go back and finish these in your notes. So if you get the notes, you'll have those. Find two positive numbers whose difference is 29 and whose product is this. Two positive numbers, so x and y, whose difference is 29, so x minus y is equal to 29, and whose product is that. So what would I have to do to get a product of those things? So x times y is going to equal 3,572. But I need to have them in terms of which is equal to it. So this is kind of an 8. They put chapter 8 into this one because I need to solve for a variable and substitute it in place of it. So if I say x is equal to y plus 29, I can go down here in this formula and take y plus 29, times it by y, and end up with my value and what it would be. So then I'd have to multiply that piece out and come up with those and what that happens to be. Do we need to finish this one? What do you guys think? Yes? No? Again, chapter 8, because I had two equations, x times y is equal to this, and x minus y equals 29. So to get it, to work it out, I need to solve for a letter, because I have to have it all in one letter to do my quadratic equation. The next one is a rectangular auditorium, and this one you will see. I know it shows up in there. So if you got a rectangular auditorium, like so, the number of seats in each row, so if I have rows and seats, so one is rows and one is seats when I look at my equation for this. So it says the number of seats in each row exceed the number of rows by 12. So seats is going to be x plus 12. Rows are going to be x. Find the number of seats in each row. So it seats this many people. So 1,900 is equal to x times x plus 12 is what comes out of that one. And you will see that one in your work. The thing that you want to do is, again, get it multiplied out, use your quadratic with it, and it'll work out to get your answer to that one, okay, for that piece. And then finally, the very last one that you had in there is find the negative real numbers, and we did this one also in here, so it's kind of a duplicate, such that the square of the sum of the number and 6, so x plus 6 squared, is equal to 1369. And so we did that one out, so you have that one in there as an example. And again, I'll go back through and work these out so that we'll have them in your notes, so you'll see them worked out. I'll probably use a different colored pen than my black one, so you'll know that they're in there. So they will be in the notes, okay? Questions with story problems? Be careful with them, read them carefully. That section does take a little bit to do. So let's take a break, and then we'll come back. Okay, let's get 10-4, get it going and get it out of the way. We went through 10-4, used to be the nightmare of nightmares. And the reason it was is because they would put so many different kinds of problems in here for you to solve and to work with. So we went through in the math department and eliminated a lot of them. And so there's down to 5 kinds that fit into this category. And they had something like probably 11 different ones, and it's just way too many to work with. And so we went and eliminated a bunch of them. And so the 5 that we're going to go through are going to be the ones that you'll see in this section. And it's equations in quadratic form. Now, some of these equations don't look like the common stuff that we've been working with. So we're going to work on making substitutions that allow the equations to be a quadratic form. We're going to solve the equations and then write the quadratic form, and then solve the equations containing rational expressions, and finally solve higher degree equations. And we're going to work through those. So what we need to do is, within these, is they look kind of strange when you see them. I think maybe if I show you one, that might end up helping. Here's one of them. It's strange because it's got different types of values in here, and it doesn't look like a regular quadratic, but it really is. So in most cases, these are all factorable when we work with them. So what we're going to do to take care of that is we're going to look at the middle term. So in this case, my middle term is negative 12x to the 3/2 power. Substitute first degree variable such as u for the variable expression in the middle term. So I'm going to take this piece out, and I'm going to put a u in its place, which means I'll have a u squared at the beginning. Then it will become something that I can end up taking the square root of. So I substitute u squared at the beginning. The result is a quadratic equation for u, and I can solve it at that point. Substitute the results back for u in the beginning of the solution, and then what we're going to end up is solving it. So let's look at one that's a little bit easier than this one that I just got done showing you, and we'll work with this one first. So it kind of looks quadratic-y because it's got 3 terms. It's a trinomial. It has 3 pieces to it, but the difference is this isn't squared out here. It's to the 4th power. The middle term is squared, so it makes our stuff look a little strange. So we're going to say u is going to be equal to x squared. So now I can say u squared minus 7u plus 12 is equal to 0. And in most cases, when you pull out those funny looking exponents in there, we can usually factor these. So what does this factor to? U squared minus 7u plus 12. Factors to u and u. Yep, -3 and a -4. Perfect. So u minus 3 equals 0, and u minus 4 equals 0. So set them both equal to 0. And I'm going to add 3. So I find u could be 3. And I'm going to add 4. And u could be 4. Okay, but that's u. That's what u means. That's not what the x value means. So now what we're going to do is we're going to take these 2 answers and replace u with what it's equal to. So we're going to take this u out, and we're going to put x squared in its place. And now what I can do is use my square root property that says if I take the square root of both sides, I will find x is equal to a plus or minus the square root of 3. And over here, the same case. And if I take the square root of x squared, I get x. The square root of 4 is a plus or minus 2. Now, the thing about these is that you don't just have 2 answers with them, and when you see your answers pop up in Hawks, there may be 4 boxes there that we need to put answers into. And so one box would have the square root of 3. The other one would have the negative square root of 3. the third will have the positive 2, and the last one has a negative 2. So you've got 4 answers to this whole thing. And what these 4 answers means is that you have a graph that's doing one of these type of numbers where it's crossing at certain points in here, like it might be crossing over here at a positive 2 and over here at a negative 2 and over here at a negative square root of 3 and here at a positive square root of 3. So that graph is crossing in a variety of places in there. So it's not just one single spot anymore that you're looking at and what's taking place with it. So that's what you're finding is those locations and those positions in there. Okay? Does that make sense? So this is type 1, where you have an x squared in the center. Type 2 is where you have a fractional exponent in the center. So this one, I'm going to say x to the 3 halves is equal to u. And what that means is I'm going to replace this with a u squared. Minus 12u plus 27 is equal to 0. And again, they're kind enough to make them so they factor. Yes, at the beginning. This is replacing, the question was, is it always u squared at the beginning? Yes, because this piece is being replaced by u. And so naturally, the very beginning one is always the u squared. Yeah. And so, what does this factor to? So I get a u and a u. And factors of 27 that give me a negative 12, well, minus 3 and minus 9. So u could equal 3 and u could equal 9. We good so far? Okay. So far we're okay. Then I need to solve. I'm not solved yet. I just have u's. If you type these in, it's not going to give you the correct answer. Okay. So be real careful with that part so that you know what is taking place with that. So now what do I do? Well, I take these u equals 3 and u equals 9, and this is kind of the trickiest one of probably all of these. Because now I'm setting it equal to x to the 3 halves is equal to each of my u answers. To get rid of the 2 from chapter 9, what was the 2? The 2 was a square root, right? And so I now need to square each side. So when I square each side, what happens? These on the x's cancel. The 3 gets squared and becomes 9. We good? To get rid of the 2 in my denominator on my fractional exponent, I square each piece. To get rid of the cube, now that I got the square gone, I need to take the cube root of each side. So x is going to equal the cube root of 9, plus or minus. We good or not good? So we take and square each side, then we take the cube root of each side to come up with what the answer is. So over here, same thing, these cancel. 9 squared is 81. So then if I take the cube root of each side, I guess I don't need my plus and minus in there. Cube root of each one of these is going to give me x. Cube root of 81, I can pull out a 3, leaving a 3. Because 81 is 2 or is 3 to the 4th power. So I can pull out a 3 and it leaves a 3. So that becomes my 2 answers to this one. So that's kind of a strange one. So be careful with the fractional exponents. Okay? So you got to do this kind of stuff with those. So that's type 2. So we had type 1, type 2, type 3. So in type 3, I've got a whole piece that's making u. So when I replace these, x plus 3 is what u equals. So now I have u squared minus u minus 2 equals 0. And I factor it. And these, again, all factor. So not one of them doesn't factor. So negative 2 and a negative 1 is a negative 2 and a plus 1. So u minus 2 equals 0 and u plus 1 equals 0. So u equals 2 and u equals a negative 1. But I'm not done because I got to get it solved. So replace u with x plus 3. This is probably the #1 mistake that's made with these, is you forget to plug them back in. And you go and type these in, and it's going to come back say, wrong. So be real careful and make sure that you solve it all the way. Minus 3. So I find x is equal to a negative 1. Add 3. I find x is equal to 2. So that becomes my 2 solutions. Oh, no, it should be minus 3. It should be a negative 4. Thank you. Yep, minus 3. And so I get a negative 4. Yes, so that should be my 2 answers. A negative 1 and a negative 4. All right. Yes, we think so? Hopefully. Okay. And this one, if you've got a number in front, this number that's out in front of here needs to be removed. So that means I need to divide everybody by 2. So remove the number in front of the x squared, or x, in this case, y squared term, or the x squared term. So when I do that, I get y to the negative second minus 12y to the negative first plus 27 equals 0. So again, a different one because now I got a negative 1. So y to the negative first is going to equal my u. The math really isn't hard with these. It's just remembering to do your substituting in. So I end up with u squared minus 12u plus 27 equals 0. And we just factored this one. U minus 9 and u minus 3. So u equals 9 and u equals 3. But I'm not done. Replace u with y minus 1. And because it's a negative exponent, what happens? What do you think happens if I get a negative exponent? What did negative exponents do a long time ago? They went where? Went to the bottom. So y is really equal to 1/9, or y is equal to 1/3. So I just move them to the bottom. So negative exponents. Move to bottom. Okay, so they're going to move to the bottom. So they're not going to stay on top. They're going to move with that one. And then this one, that one I can factor out an x. Leaves me with x to the 4th minus 49 equals 0. This piece factors. So this one, there's no u substitution. So no u substitution. So set each piece equal to 0. Use my square root property. Take the square root of each side. So I find x is equal to plus or minus the square root of 7. The last one, minus 7. Square root it's both sides leaves me with x is equal to plus or minus I, the square root of 7. Now in Hawks, you'll have 5 answers. 0, the square root of 7, the negative square root of 7, I, the square root of 7, and negative I, the square root of 7. So there's going to be 5 answers to this thing. So it's got the most of all of them. So it's kind of doing with some imaginary pieces that are in there. And then this one's the last one of the different varieties that we happen to have. And this should be actually F instead of E. And again, no substitution because z squared minus 3 and z squared, yep, plus 3 is equal to 0. So I just factor it. And so z squared minus 3 equals 0 and z squared plus 3 equals 0. And use my rule. Move my 3 over. Take the square root of each side. So z equals a plus or minus the square root of 3. And last one, minus 3. Square root each side. And I get I, the square root of 3 with that one. So that's my different varieties of each one. So hopefully you have those. I do have some practice ones that are in here. We can pick out some of those if you want to do. Again, just remember to replace your U's and make sure you put the U's in place of what you happen to have. This one, replace with U, and then factor them. Replace this piece with U. Replace this piece with U. These two, factor as they are, and this one, replace U with those. And so, any of those that you think we need to go and do an extra one on? Are you good with them? What do you think? I only did one of each kind, so I hope that's enough. Here's the answers to them worked out. We'll leave this up here. Again, trying to fit the whole thing in there. I might have to raise this up just a tad. That'll help. And so that's 1 and 2. Again, stop it if you need to see them. And then here's 3. 3 is kind of the one that has the most pieces in it. Yep. Okay. So there's 3. And so it's worked out. Again, I ended up taking this piece out of the middle, replace it with U, factored, worked each piece out, replaced U with what it was equal to, solve for Y, and I get a fraction, and I get a regular number in there. And then finally, number 4, I guess I've got a couple more to go here. That one has the 5 answers to it because, again, you're factoring your pieces in there. And then here is 5 and 6 worked out in there too. So you got those 2 pieces in there. So again, with that part, that's what happens to those. And then finally, those are the answers that would work out to those. Again, I'm leaving them up there so that if you want to stop it, you can at that point. So. Okay, that's all for today with what we got going.